over the first 4 sections is because when you get to section 5, what is the word that starts off the title of this section? Inverse. Inverse circular functions. So that means we're going to be working with inverse sine or arc sine. Remember when we talked about the angle whose sine is, and we have the ratio, we're trying to find the angle. So let's just kind of review a few things. If you took a good algebra course, you should have had a discussion about what inverse functions are. In fact, I'm starting that today in the class after this one. So if you feel like, oh, I don't know what that is and you don't have class, feel free to stay if you want. But inverse functions simply mean that if you had the original equation and you switch the x and the y, you've created the inverse, okay? Now, remind me, there's a rule on how I know if an equation is a function. Do you know what it is? It would have to pass a vertical line test. Basically, what that means is for each x, there's exactly one y. Now, we got a little bit of an issue with if we're going to create inverses, because, for example, if I had, and let me just put a sketch on here, something like y equals x squared, which would look like this when I graph it, okay? And that's a function, agreed? Passes a vertical line test. But if I try to create the inverse, I'm supposed to switch the x and the y. Is that going to be a function? The answer is no, because if I were to switch these, that's what it turns into. Will it pass a vertical line test? No, that is not a function. So in order for a function to have an inverse, it has to be what we call a one-to-one function. That means not only would it pass a vertical line test, but if I'm looking at the graph, it would also pass a horizontal line test. Okay? So that when you switch it, you would also get a function. Okay? And this is just explaining what we just talked about. Switching the x and the y is how I'm going to get the inverse. And this little, it looks like an exponent to the -1 power, but it is the symbol we use to represent when we're looking for the inverse. Kind of like on your calculator, where you see above sine, you've got sine to the -1. That's not saying that you're raising sine to the -1 power. That's saying that's the inverse sine, or the angle whose sine measure is whatever. So this is just reminding you it's not a negative exponent. Instead, it represents the inverse function. But it's not 1 over the function. Those are different things, okay? I know it's confusing sometimes when we recycle symbols or we recycle vocabulary in math. It's kind of like range. The word range has more than one meaning in math, depending on what you're working on. So just be careful on this when we're talking about inverse functions. That's going to be the symbol we use. Now, in a one-to-one function, how many x values correspond to y values? It says each x value corresponds to only one y value, and each y value would have to correspond to only one x value. Good. Now, if some function is one-to-one, okay, then there will be an inverse function. That's the only way you get an inverse function, is if the original is 1-to-1, okay? Now, think about this for a minute. If what I'm doing is switching x's and y's when I create an inverse, then the domain of the original becomes what in the inverse? Right. Yes, there you go. And the range of the original becomes the domain of the inverse. Okay, so if we were giving a specific example, if I had an ordered pair A comma B on my original graph, what point do I know would have to be on the inverse? B comma A. There you go. And this is also an important property if you were ever looking at graphs and trying to decide if they were inverses. That's one of the things that we do in college algebra. There has to be a line of symmetry that would exist if I'm looking at a function and its inverse on the same graph. Where do you think it would be? How do we get the inverse? We do what? Switch the x and the y, right? So guess where my line of symmetry is? It's at y equals x, okay? When y and x are the same thing, that's going to be a diagonal line that goes through the first quadrant and the third quadrant. And as long as these graphs would be reflections of each other across that line, y equals x, that I could fold on that line and the pieces would match up exactly, that's how I know I would have inverse functions. Okay, and in fact, while I'm thinking of it, since I have these notes with me, let me show you real quickly. This is one of the things we'll look at. This is that y equals x line. If these are inverses, when I fold there, what's on this side would have to match up with what's on that side. Clearly, that's not going to happen on this one, right?
Right.
But if I were to show you, let me show you this real fast. This graph, there's my y equals x, and if I were to fold, would this line up on that? These are inverse functions, okay? So that gives you a little bit of a visual to understand, hopefully, what it would look like graphically. Now, here's how you would find your inverse function. First thing you got to do is what with x and y?
Switch.
There you go. So we are going to replace our f of x, if it's written in function form, with y. So I see an x and a y. And I will switch or interchange x and y. And if it's easier to write down the word switch instead of interchange, feel free to do that. All right. Here's the other part that we have to be careful about. If I leave it in this form, it's not considered to be written in function form because it needs to say y equals. So I would need to then solve the equation for y. And after I have done that, then I can replace y with the symbol that indicates I have found the inverse function of x. Okay, so if we're going to write inverse functions, that would be the process you would go through. You take the original function, switch the x and the y, and then solve for y. Okay?
Switch, solve for y,
and then, yes, that's it. That's all there is to it. Now, the inverse sine function looks like this. Y equals the angle whose sine is, that's what arc sine means. Or if you do it this way, that's perfectly okay too, but that doesn't mean 1 over sine of x. That means that we're looking for the inverse. Now, here's the issue. You know how we had those graphs up earlier on what sine and cosine look like? If I don't put some kind of restriction on the domain, because sine is a curve that does this, if I switch it, instead of snaking around the x-axis, it's going to snake around what?
the y.
Exactly. Now, if this thing starts doing this, is it going to be a function?
No.
No. Just like we had a problem with that x equals y squared not being a function, if we don't set a restriction on the domain, it won't be a function. So here's what we will do. We are going to put an interval for sine. We're going to go from negative pi over 2 to positive pi over 2. Basically, you're either going to choose quadrants 1 and 2, or you're going to choose quadrants 1 and 4 for your sine restriction. Why would we not want to use 1 and 2 for sine? It's positive in both of those. I've got to have one quadrant that's positive and one quadrant that's negative. So with sine, if we go quadrant 1, quadrant 4, then we'll get all the ratios. Okay, so it'll just give us that section of the original sine graph if we were looking for it. Now, I know the domain of arcsine is the same as the range of sine. What's my range on sine? Be careful. Think about those y values. If I'm graphing sine, what's my high? What's my low? So my domain, because I've switched them, will be between -1 and +1. Okay? Because I'm putting in the ratio values when I'm working with arcsine. And the range is going to be this restriction on the angle measures, only from -π/2 to +π/2. Okay? Now, let's see if we can find the value of these, if it exists. All right? So if y is equal to the angle whose sine is √3/2. Okay? Ideas, strategy. What would you want to do? Could you what? Your unit circle?
Yeah.
You could look at your unit circle. What were you going to say, Cassidy? I'm with you. I'm kind of a draw a triangle kind of gal. So I would need to know where sine is going to have a ratio of √3/2. Now, since I'm restricted to quadrant 1, quadrant 4, which quadrant am I in? Well, is that a positive value or a negative value? So if it's positive, wouldn't I be in quadrant 1? Okay. And since sine is what over what? Opposite over hypotenuse. I would have √3 here. I would have 2 here. Does this look like a special right triangle? Yeah, what goes here? So that means this angle measure right here is what? 60 degrees. Now, I could leave it as 60 degrees, except if they give me this restriction in radians, I should change it back to radians. So how do we change 60 back into radians? Multiply it times π/180, so that's going to be π/3. Does that make sense? And as Erin said, yes, if you want, you are welcome to use your unit circle. So if I were to look here at the unit circle, and I'm looking for the angle whose sine is √3/2, since sine is opposite, that means it's a y value, and I look over here, there's where the y is √3/2, and I can pull it off of here just as easily, okay? Beg your pardon? Oh, I thought I had a question. Okay, now, this looks almost impossible to read. I do not know why it did this instead of this. This is actually the angle whose sine is a -1/2. All right, so tell me about quadrant on that one. Am I quadrant 1 or quadrant 4? Because that's where I'm restricted with sine. And the reason I know that is it's negative. So I need to be in quadrant 4 because that's where sine is negative. And then did you have a question, Shanae? Yes, the inverse has to have a restricted domain on it in order to, well, the sine function domain is restricted so that when we take the inverse, it'll be 1-to-1. Yes, and that's why you're going to be restricted to just 2 quadrants. It's either 1 or 4. Okay, because otherwise it won't be a function. That thing will just wrap around the y-axis. So what angle measure has a sine ratio of 1/2 in the 4th quadrant? There's -1 for opposite. Hypotenuse is 2. That means this is √3. This angle measures what? Yeah, remember, if I'm doing the 3rd quadrant, instead of writing it with a negative angle measure, I would probably want to use the positive. So to go all the way around here is how many degrees? I think I heard you say it, Aaron.
30.
330 degrees. Or if I turn that into radians, that would be 11 pi over 6. Okay? Which is also a negative pi over 6. If you wrote it with a negative. All those are equivalent. So it kind of depends on the way the question is worded in my math lab, which form they may want you to type in. So I'm just going to write them all down so that we'll be sure we've looked at it. Now, what about this one? We want the angle whose sine is the square root of 2. What do you think? In which one? You think it's in quadrant 1? What angle would have a sine ratio of square root of 2? Are you sure? If I sketch a 45, 45, 90, that's a 1, 1 square root of 2. What would be the sine? It wouldn't be square root of 2, it'd be what? 1 over square root of 2. Check that value. How much is the square root of 2? Put it in your calculator. What does it tell you? It's how much? No, just square root of 2. I just want to know what that number is.
Square root of 2.
1.4 something, right? What's my domain? I can't get anything that would give me a ratio for sine unless it's between -1 and +1. If they give me a value that's not in that domain, this does not exist. Be careful. They may be sneaky on that. So notice it said, if it exists, that does not exist. There is no angle measure whose sine ratio is greater than 9.
Won't you see those, like, in the test? Or?
Most likely not, but it is something you should always be mindful of. Yes? Okay, if you took 330 and you multiplied it times pi over 180, okay? So I know my zeros could cancel. I noticed that what's going to be common factor looks like 3. So 3 goes into 33 11 times, 3 goes into 18 6 times. So that's how I got the 11 pi over 6. If I thought of this as -30 degrees, that would be a negative pi over 6. So I could use any of those methods to be able to come up with whichever form I need. If they want a positive radian measure or a negative radian measure, or they want it in degrees.
So -11 pi over 6?
No, it would be a positive 11 pi over 6 if I'm going with a positive rotation. If I go with a negative rotation, then it's only negative pi over 6. Okay? All right, we're going to stop there. We're out of time.